It's small enough that I'm happy to do participant introductions as well as TA. Um, I'll leave that up to Professor Wells. Here's Professor Wells, and then I just started here.
Let me know when you're ready for me to start.
Yeah. So you have the staff profiles, introducing hosts and instructors, mission statement. I'll just try to follow your lead on clicking through, and then I think this is where I start.
Okay. Are you ready? Oh,
Yeah, yeah, whenever you're ready to start.
okay. I'm going to let uh, Chima
Yes.
read the mission statement because we're both hosting this workshop. So I'm just going to start off the introduction and you can just take over. Is that
Okay.
okay with you?
Okay.
Okay. All right. So is everyone's ready?
Yes.
Okay. All right. Hello, everyone, and welcome. We are so excited to have you here as we begin our journey into programming through robotics. It's a hand-on, creative, and empowering ways to explore technology and bring ideas to life. Whether you're new to coding or just curious about how robots work, you're in the right place. So I am honored to introduce Black in Robotics. It's an organization that's dedicated to increasing the presence, the visibility, and the impact of Black professionals in the field of robotics. And my name is Angela Wells, and I am so proud to be a part of this mission. And we are joined here with our fantastic facilitators, Alex, Ray, TJ, and who's going to bring their knowledge and passion and encouragement to this session. We're here to support you as you learn and build and grow. So I'm going to turn this over to my to Chima, and she is going to take it from here.
Hey everyone. I hope you can hear me. I was having a little bit of a problem with my headset, but I am back. So everyone, welcome, welcome. Thank you for joining us here. As you can see on the screen right there, we have the mission of Black in Robotics, which is to bring together Black researchers, industry professionals, and students in robotics to mutually support one another and help us navigate the academic, corporate, and entrepreneurial paths to success. Another one of the mission is so that we can advocate for diversity and inclusion and equity within the organizations that we all work and live in, and to ensure that we have a seat at the table during the development, testing, and deployment of any robotic systems that affect our communities, and even those that don't affect our communities, just to add to that, and to amplify our collective voices for calls for social justice. I don't know if Dr. Maynard is with us here. He can talk a little bit about the history of that, of how this all started. It was right around the time that George Floyd incident happened, and that led to the collections of of Black people coming together for us to have a collective voice around social justice and ensuring that robotics has the inclusion and diversity and equity needs for it to be successful. So I'm going to jump off that and allow the facilitators to introduce themselves, and so we can kick this off.
All right. Thank you, Choma. I believe Professor Wells introduced us, but when we jump into our respective parts, we can also briefly do a small reintroduction. So I'm Alex. I'll be filling in for TJ on the robotics part, and just starting with framing the workshop and the code. So our learning goals is first to change and iteratively write Python code. Mistakes are a big part of coding, and we expect that to be part of the process. So writing functions and writing expressions, so writing the code and calling existing functionality. In order to command a robot to do these two tasks, you'll be able to command a robot to joint angles and to a 3D location in space. And then finally is we'll combine these skills to perform some sort of compound robot behavior where you'll have some choice in what we'll do, either a robot dance or a pick and place. We don't assume any programming experience. If you do know how to program, some of this might be pretty easy for you. Okay, but the main point of this workshop is to develop the confidence that you can do robotics and programming. Here's some interaction expectations. This is really small, so we're going to be pretty relaxed with this. In the main room during lecture, we'll have some questions. You can either answer in the chat or just unmute yourselves. During the lab, we will have breakout rooms, and you can decide which one you want to be in. The main room, you can come back if you have any problems with the code or any help. Please don't spend more than like 5 minutes being stuck. There's really no reason to. Um, in your breakout room, you'll discuss the questions with your group. This is where we expect all of the learning to happen. The students and the TA will work through the lab together. And if you're having any trouble with your network connection, Ranisha is an expert in this, and she suggests to turn off your camera. And I think there's a way to turn off incoming cameras as well. And most of all, everyone is important here, so we're going to treat each other with respect and kindness that we all deserve. Questions about expectations? The short. Yeah, and this will be pretty flexible. It'll be whatever works best for y'all. This is an outline. We'll have this was the introduction. This is the longest lecture will be 15 minutes. Then we'll go into a breakout room to work on the lab for about 20 minutes. Then there will be 2 robotics sections with a short 5-minute lecture, and then we'll go into breakout rooms and then work on the labs, and we'll check in on the breakout rooms to see where everyone's at. And then wrap up will be combining the skills together, and again, a 5-minute lecture, and then mostly working on the lab. And then we'll come together at the end for about 10 minutes. So this is kind of what to expect on the structure. All right, I'll give 10 seconds for any last minute questions before I hand it off to Ranisha and we'll jump into the programming section. All right, Ranisha, you can take screen sharing. We're on your part now.
Okay, let me,
I think you can just take it away from me, but let me know if I need to stop it.
yeah, I'm trying to move some windows about. So they're in the right places. Okay. Actually, why is this not doing what I wanted to? Sorry, just give me a minute to rearrange a bunch of windows. Okay, and then let me share my screen. I think my screen is being shared. We can all see programming in giant letters.
Yep.
Yes.
Okay. Great. Hi, I'm Ranysha Ware, but everyone just calls me Ray for the most part. And so today we are going to cover some programming concepts. As Alex mentioned, we're assuming no programming experience. So for those that do, especially in Python, this will all look very familiar. So first we're going to talk about how do we get computers to do the things we want them to do. So what is programming exactly? Well, programming is just a recipe consisting of definitions and commands. So let's say we want to tell a computer to make a peanut butter and jelly sandwich, and we'll just do this in English. So the definitions here are underlined and the commands are in bold. So here we have definitions that are labels for terms. So we have labels for slice 1, slice 2, and jelly. And the commands are the actions or instructions. And here we have spreading and placing. So our final program then is just a series of instructions on how to make a sandwich. So here our program is a series of instructions in English where we have this recipe, make a peanut butter and jelly sandwich. And so we need to instruct our computer to lay 2 slices of bread on a plate, spread jelly on slice 1, spread peanut butter on slice 2, put the slices together, etc. So here our instructions are in English, but a computer needs to know how to take these instructions and turn them into something that a computer can actually perform. So in addition, some of these terms need to be arranged in a particular order so a computer can understand them in the same way words in English need to be in a particular order for us to understand them. So we define the instructions a computer can understand in something called a programming language. So programming language is just language for coding with its own rules of how letters and numbers can be arranged and what that arrangement is going to mean in terms of what a computer should do. For example, if we want to write an addition command, the language requires we write a plus sign between 2 numbers. So here, an example, if we wanted to add 2 plus 2, we'd need a 2 followed by a plus line followed by another 2. So what if we want to write a definition? Well, if we want to define something, we have to write an equal sign between the label we want and then its value. For example, here, if we wanted to take the sum of 2 plus 2 and assign it the label x, we'd have to have x followed by an equal sign followed by 2 plus 2. And so this is a requirement for the language to be able to do the sum and assign it a label. So there are many different programming languages, all with different rules about how to define a series of instructions. For example, here are 2 example programs in a programming language. At the top is Python, which we'll be learning today, and another called Java, which is on the bottom. And note, both of these programs are doing the exact same thing, which is computing the sum of 2 numbers and then printing that result. But there's a different arrangement of words and numbers to do these same actions because we're looking at 2 different programming languages. Sort of like if you have 2 different languages for spoken word, you can say the same thing, but you're going to have a different arrangement of letters and symbols. So for example, to store the value of 2, Java requires we write something called an int followed by the thing we want to be the name, followed by the thing we want to store. So if I want to store 2 in a variable, which we'll learn what that is later, I'd have to write int first equals 2, where in Python, we can just write the label, which is first, an equal sign, and then a 2. So these are both doing the exact same thing, but we have different rules for those arrangements of symbols and letters. Sometimes we also call this the semantics for a language or the syntax. And so next we're going to talk about different programming language fundamental concepts, and we're going to learn those concepts in Python, but they are applicable across programming languages. I'll stop here if anyone has any questions so far. Feel free to just unmute yourself or drop something in the chat. I can see the chat.
I have a question, Ray.
Yes.
So Python is, does it require like software that is required to write, like, or is it just like HTML on a notebook and then how does that work?
Yeah, that's a great question. So we do need to install something on our computer to be able to run Python. It is a programming language that's going to work on your computer, where something like HTML, you can work with it in the browser. With Python, you do need to install stuff to write Python. Does that make sense?
Yeah, it does. And okay.
It's the same thing with Java as well.
Okay.
Good question. Other questions? Okay. All right. So what are the concepts we're going to talk about today? We're going to talk about what is a variable, how do we print things to the screen, how do we write comments, how do we define functions, and how do we sort of store a list of items. I'm going to do some live coding, which could be a disaster, but it should go well because I've done it before. But please pause me for questions. I don't know what you just said. Can you start over or put questions and comments in the chat? I will also ask questions of the audience. And I'll just wait until someone says something. So hopefully we get some participation. Cool. All right. So first, let's talk about something called the print statement. So we saw this a bit on the previous slide, but the print statement in Python is just used to print text or other objects to the screen for us, the users, to be able to see what the program is doing. So it's one of the most basic and important statements in Python. So let's walk through the syntax. So again, the syntax is just going to be the series of symbols and letters that are going to allow us to print something to the screen. So the syntax for this is the word print, followed by an open parentheses, a quotation mark. The text we want to print here, it's going to be hello world with an exclamation point, a quotation mark, and then a closed parentheses. So this will print hello world. Okay, I'm going to attempt to show you this. This is letting me run Python in the browser, but you, as mentioned before, if you want to run Python on your computer, you do have to install. But this lets us do it here in the browser. So I'm going to write print and then hello world and then run this. Where did it? Oh, that's why it's not printing. And then it's going to print hello world. So I can print other things. I'll print, hi, my name is Ray, and run this, and I'll print that. So, questions about printing things to the screen? Great. All right. Now let's talk about comments. So comments, again, are going to be useful for us as humans to be able to write explanations of what our code is doing. So this is notes and stuff for us as the user, not for the computer. So the syntax for a comment is a single line is going to be a hash sign, hashtag Black and Robotics. That was a joke. So a hash sign like you would use when you're doing like hashtags on social media, and then anything after the hash sign, the computer is not actually going to run that. It's just going to be there for us as users to be able to see some notes about what we're doing. So if they're used correctly, it can help us explain code. It can also be used to run unwanted code. So if we go back to our example here, and let's say I have output something. So this will print something to the screen, but if I had an hashtag in front of this, and you can see the color of it changes, now if I run this, it's not going to print anything. So oftentimes if you want to add a comment, I'd add the comment before whatever the code is that I want to run so that I, as the person, the human, can have some notes about what the code is doing.
Okay, Ray, I have another question.
Yeah.
Okay, so this is being done in Sandbox, which is like is like an app or something that
Yeah, so this is
demonstrates what
this
happens.
Yeah, so this is CSCMU Academy.
Okay.
It lets you, I'll just go back.
It's like W3 schools for HTML kind of CSS kind of thing.
Yeah.
Okay.
So at CMU, they started this program to bring CS education to high school students. And so they started CS Academy. It's actually academy.cs.cmu.edu for anyone who's interested. And here you can just run Python code in the browser using this sandbox.
So that was one question. Two, are you guys going to record this and send this back out to us?
There is
Yes,
a recording.
it's recorded.
Okay. I know there's a recording. I don't know what happens to the recording after it's recorded, but there's a recording. Yes.
So was that a yes that we can get this later?
I mean, should be recorded unless I don't
Yeah,
I
yeah,
see
it's being
stops.
recorded.
It's been recorded.
Okay.
Okay.
We can
And
send it.
two, I'm on the internet all the time, and I just got this and it's kind of popped up. So let me ask another question. Who is this open to? Is this open to, like, can we get more students in this space? And the reason I ask is because I'm about to start a melanated robotics competition team, and this would be great for my teams to be able to have this. How long are you guys going to do this? Is this for a quarter? Is this for a grant? How long are you guys going to do this, and how many sessions is it? I may have missed this information. I don't know. I just kind of came in.
So this is the Black in Robotics Summer Events Workshop. So
Okay.
they have different things that goes on here, but it's all tied to robotics. And for today, we're doing the one for beginning coding in Python, and they're going to be programming a robotic arm. But we've
Oh,
done
got it.
things like machine learning, um, Arduino, and anything related to robotics.
Oh,
I
okay.
don't
So
know
this is
if
a
we have another one of these
series.
sessions. Yeah, we have different things going on.
And is it possible that I can get the video for each series that you guys have you've done? I'm sorry. I'm
Yeah,
not.
we've recorded most of it, but we can talk about this later, so we can
Okay.
just like keep so we're not delaying the
The
session.
pictures.
Yeah.
Okay. Thank you. Uh-huh.
Yeah.
Great questions. Okay. Next, let's talk about variables. So as we mentioned earlier, we can assign labels to data. So we call these labels variables. They are similar to how we see variables in math, but not exactly the same. So we take whatever expression is on the right side of an equal sign and give it to the label of what's on the left. And once you've assigned a value to a variable, you can then do operations with that variable like it's that value. So let's look at an example. So here I'll have some variable name. I'm just going to call it variable name. And I'm going to set that equal to 2. That's not going to print anything for us because this is us just storing a value. But now I can say print variable name. And that's going to print 3. Because now whenever I reference variable name, it has the value 3. And we can do math, which we'll talk a little bit more later, but let's say I wanted to add 2 to 3, I could do this. Questions about variables? Okay. Oh, this is what I like to do. So let's say let's say I'm gonna have A, I'm gonna set it equal to 7, and I'll have B, I'll equal that to 10. What will this print? Anyone from the audience? If I have this
7
code,
plus 10.
yes, which is
17.
yes. So that will print 17. Cool. All right. And then I don't know, Alex, if you want to talk about breakout room expectations.
Yeah. Again, these things will probably be a bit different. I set up 2 breakout rooms. The way we do it to make sure that it's student focused is that one student will share their screen and work on the code at a time. As a reminder to both TAs and students, it's better when the student does most of the talking. Anyone can ask questions, TAs and students, but even if one student is kind of leading at a time, everyone should fill it out in their version of the notebook, which I think will be next slide. But try to rotate who is sharing their screen each section so everybody gets a turn. As for pacing, some of them are challenges and some of them aren't. It's really designed so that if you're more stuck for more than 5 minutes, it's not a reflection of you. It just means we're probably not communicating something clearly enough. So please just come to the main room so we can clear it up. That goes for TAs and students. All right, next slide.
I think this is slightly out of order. We're gonna come back to this because I think this is out of order. I think this is supposed to come later.
Yeah.
Okay, we'll re-say all of that briefly in a moment because I'm still supposed to
Okay.
be talking about how to code. Okay, hold up, pause. Um, okay. I have a little bit more coding stuff to talk about before we go to breakout rooms. So I think that was slightly out of order. Okay. So we talked about variables. Next I want to talk about functions. So we've actually already seen a function. Does anyone have any thoughts about a function we might have already seen in a previous slide? Hint, it's on the screen right now. Okay, it's the print function. So A function takes as input something called arguments. So sometimes there can be no arguments to a function. But like we've seen with the print function, we go back here, it takes some arguments and then it's going to print that to the screen. And then, so we pass arguments and then it's going to do something when we call the function, and then it will return something, when sometimes it might not return anything. So let's do an example. Let's see, what's the other built-in function? Is it max? Max built-in function? Trying to remember. Oh, yeah. Okay. Yes. Okay. So for example, in Python, we have a function called max. And so the function is called max. So you put the name of the function, and then it takes any number of arguments. So to specify the arguments to a function, it's whatever the value is, followed by, if there's more than one argument, you follow it by a comma and then put the next argument. So this one actually takes any number of arguments. And then I'm going to just store this in a value. I'll give it a variable name called number, and then I'm going to print this. Any ideas what this will print? The max function takes the max value of the arguments. Anyone know what the max of 1, 2, 4, 5 is? I know we got some smart people in here. It's 5. I'm going to pause for questions because I got no response there, so it's possible folks are confused.
Well, there's a response in the
Oh,
chat.
there was a response in the chat. Oh, that's my fault. I did not see the chat. I said I was going to see the chat and then I didn't. That's my bad. I see 5. Thank you. Thank you, Michelle. So yes, it is 5. Questions about function. So in this example on the slide, we'll say we have some function called divide that takes 2 arguments, and then it will just divide the 2 of those arguments. Any questions? This part can be very confusing for folks new to programming, especially programming in Python. Okay. All right. Last topic, which is, let's say we want to store data in more than just variables. Okay, let's say I want to store a series or collection of data. One way I can do that is using a list. So let's look at the syntax for this. So here I have an example where the name for my list is going to be my list, and I want to store the values 1, 2, 3, and 4. So the syntax for defining a list is brackets. So I'd have open bracket like this. And then the values I want to store in the list, and sort of like the way we define arguments, we're going to put the values separated by commas. So here, this is me defining a list with these values. And then I'm going to print this. And it's going to print those values. So in the chat, can y'all write a different list? The syntax for a different list. If this is an example. So here I have an example of a list of 1, 2, 3, 4. In the chat, can I get another example of a list? Nice. I've got a list from Alex with 0, 3. Chioma with garden lab bed. Love it. Okay. So another list might be something like this, which has the values 0 and 3. Okay, questions about lists and defining lists. Okay, next we're going to talk about modifying lists. So here, I'll just run through this slightly quickly in the interest of time. But let's actually go back to our code here. Whoops, I forgot I was not showing you this. Okay, let's talk about modifying lists. So the same way we defined a list using those brackets, we can actually use those brackets to index into the list as well. So let's go back to our list. Let's say we have 5, 7, 1. I can get particular values of the list by using indexing. So typically indexes start at 0. So the 0th element in this list is the number 5. The first element is the number 2, and the second element is the number 1. So I can print the first element, or the 0th one, by doing the name of my list, open bracket, the index of the item I want to access, and a close bracket. So this is going to print 5. Who can tell me what this will print? Now I've changed this to my list 2 in the chat. What will this print? 1. Beautiful. So remember, indexes start at 0. So the first thing is at index 0. The second element is at index 1. And the third element is at index 2. So here's an example, another one where if I have my list 1, 2, 3, 4, 6, and I did my list 4, that would get me the element 6. Questions about modifying lists? So here I'm just accessing elements. So I can actually access elements and then change that element. So here, right, so my list 2 gets me that element 1. What I can do instead of printing this is I can update this value to something like 6. So this will say take the element at index 2 and set it to the value 6. So it's somewhat similar to the way we were defining variables, where we have the thing on the left is going to be, the thing on the left is going to be assigned the value on the right of this equal sign. So now if I print this list after I do this modification, I now have the list 576 instead of 571. So this is before I modify the list, and then this is after. Okay. We're like way over time now, but here's another example on the slides. Questions about this? This is the last topic we're going to cover. So also feel free to ask any questions about anything we've talked about so far. Great. Either that was super clear or I'm a horrible teacher. I'm going to go with the
It
first.
was clear.
I'm going to go with I'm an excellent teacher, and that was very clear. Okay. Alex, I don't know if you want to come in and remind us about the breakout room
I think
expectations.
so. Also, I think you did a great job. I think things will become more clear when people get to get their hands dirty with the code. So yeah, just next slide. Yeah, so the way we run the code is we have this notebook. And there's, in order to edit the codes or change the code, you can double click the code block and type. And then to run the code, there's just a play button on the left of the code, and then you can see the output below. Text is the same thing. There'll be places to put answers if you want to record answers to questions. And you can double click the text block and type. All right, so our first lab is going to be programming. So first, spend just a couple minutes getting to know each other. I think we had some what's it called? Icebreaker questions. So give your name, what interests you about robotics, and something you want a robot to do, how you describe the instructions for the robot to do that task. We'll spend 15 minutes doing the lab, but we'll check in to see if we need more or less time. There's a QR code and a link. There is more text than I think we would like, but you only really need to read the stuff in bold. Yeah. And yeah, work with each other. Remember, one student sharing screen at a time. I think we won't do the pretend breakout. Ray, what do you think?
I think yeah, we're a little bit behind on time, so
Yeah.
I think
All
y'all.
right, so I think I already created the breakout rooms. Make sure there's at least one TA in the breakout room. So TAs, please distribute yourselves. And students, I think you can also like move yourself from breakout room to breakout room. So if the vibe's just not for you, feel free to switch. Yeah, if you get stuck, you can either come to the main room or I made a help room. All right, any questions before we get started?
Do you want to drop the link in the chat?
Yeah, that'll make things more convenient. I'm actually going to drop the actual link because Bitly is now putting ads in.
Really?
Yeah, which I get, but well, I'm doing the free version. This should not give you any ads. All right. All right, breakout rooms begin and questions. You can come here. Open all rooms. You should have received an invitation to join a breakout room. I assigned them, but you can move them. I'll pause the recording. We have a lot of workshops this time around, but it's cool. I think people really like the kit workshops. Is the drone workshop a kit workshop?
Oh, okay. Oh, people are coming in.
Yep. Let's look in the chat
Hi,
again.
Serial.
All right. How did the lab go for folks?
It was good. It allows you to get hands-on with the collab space.
How far were you able to get?
We got to variables.
Okay, all right, that's important. I think once you get to functions, then that you're pretty set for the robotics coding portion. Otherwise, it might be hard. All right, I think everyone's here. Yes, everyone is here. So, yeah, I hope you got at least started on the coding portion. We're going to do a little bit of basic robotics. I think I at least heard one breakout room start chatting about it already. And this will be pretty short, and then we'll go into the lab. All right, so starting off with what is a robot arm? We're describing this as some sort of machine that kind of looks like an arm that can perform a task to get some desired results. Robots are nice because you can replace humans in tasks that would be otherwise dangerous or stuff that we just don't want to do. There's probably a lot of things that you might want to program a robot arm to do. Yeah. More fundamentally, all a robot arm is its joints and the straight parts of the robot that we call links. So just like we have joints on a human arm, we have joints on a robot arm. So on this robot arm, we have 1, 2, 3 angles, and we control those angles to move it. And that's how we move the arm. Now you get the where the robot parts are from the joint angles. So just looking at this diagram of a robot, how many joint angles does this robot have? There isn't really actually one correct answer. But yeah, let's just see what people have. How many joint angles does this robot have?
3.
1, 2, 3. Yep, that is one very reasonable answer. Anyone have any other answers?
So if you count the other ones, the other parts of it, like the wrist, the hand, like it could be 5 or 6.
Yeah,
or
good.
4, depending on how they're separated.
Exactly. That's a really good answer. Because this is so abstract, you can't really see it. So the grippers might be able to also move separately. They might have to move together. So it kind of depends on your actual robot. All right, so to get the position, now what's really useful to us is the position of the gripper. That's what we usually want to specify. So, oops, okay. So to go from angles to the position, you'll do some math, maybe some trigonometry. We don't go into the details of that. Maybe you know how to do that. Maybe you'd have to figure it out. But that will give you the position of the robot part. The position describes where the object is in 3D space. So we can use a coordinate system, which has an origin and axes. So let's say we have a point. What is the center of the square in just x and y coordinates? This is the x axis, this is the y axis.
It looks like 2, 2.
Yep. Yep. So that's 2, 2. And then if you move it over here, then what is the coordinates?
1, 2.
Yep, that's right. And it's the same thing in 3D. Because our world is 3D, you also have the z-axis. So x, y, and then z is the last one. So what would be the z coordinate for this point? Estimate it.
Are you doing center of the surface or center of the actual
Oh,
3D square?
good question. I'm doing the center of the actual cube, or yeah, center of the actual cube. Just guesstimating here, it's probably around like 1.8, maybe 2. But yep, 3D coordinates is just the same as 2D coordinates. In our robot world, the z-axis is pointing up, the x-axis points out of the page, and the y-axis points to the right. Whenever you need these coordinates, we'll plot them. So this is the robot. Now, the block is at 0.8, 0.10. So that's the coordinates of the block. Now, let's say we want the robot to grasp the block. We can tell to go to a position. A useful position would be some position that's above the block. Write an example position in 3D coordinates that would be above the block. So you can either say it or write it in the chat. Oh, my screen timed out. Interesting.
Okay, I'm totally confused. I'm used to X and Y axis. Where does Z come from? Did I miss that? Like,
Yes, that is a good question. So our world is in 3D. I think my browser stopped. That's interesting. Oh, it
so is
crashed.
that why you've got three coordinates, three coordinates? And what do each one of those points represent? The one X, one Y, then one Z? Is that what you're saying? Is that each one of okay?
Yeah. So in the example I had before my computer crashed because it's too old, the X and Y plane was on, oops, that's share. The X and Y plane was on the table, and then the Z is how far up the block is. So if we look at the Z axis, the block was at 0.8 right here, 0.1 in Y, and then Z is 0 because it's on the ground. So what would be a position that's above the block?
In chat, they're saying point
Oh, I see.
one,
Yeah, so
0.1 and 1, 0, 0.12. Okay.
yep, so these are meters. That would be really high, but those are indeed above the block. So 0.8 is just, yeah, that would be it wouldn't be a good place to grasp. Maybe you want to go 10 centimeters above, which would be another 0.1, but it's true. Those are above the block. Now, when we can't command the gripper to just float in 3D space to exactly where we want it to go. So instead, we use another mathematical tool called inverse kinematics, which given a desired position of a robot part, which in this class will be the gripper, it computes the joint angles required to reach that part. So let's say we want to grasp above an apple or a block, we can give it this position. So our input's a position, and the output is the joint angles required to achieve that position. All right. I'm going to pause there and give people at least 10 minutes for questions because this is a pretty core concept.
Are you sharing your screen?
Oh, no. Yeah, after it crashed, I stopped. Thank you. Thanks. All right, I'll redo that. So, yeah, position of the robot part is the input, and in this class it's the gripper. Inverse kinematics does some math, and it computes the joint angles required to reach that position. So then you can command the robot to go to those joint angles, and then it will end up at that position. All right, now I'll pause 10 seconds for questions. All right. Using these concepts, especially inverse kinematics, we are going to move a robot's position. So remember, from joint angles, if you specify the joint angles, forward kinematics give you the position of the robot part. And what we will be using is giving a desired position, like the coordinates that you put in the chat. And then a mathematical module will compute the joint angles to reach that position. And then you'll command the robot in the simulator to go to those angles. So the first part is you're going to call functions to move an arm to given joint angles. That's kind of the fundamental task. And then the second part is you'll move the arm to a particular position using inverse kinematics. So this is what the positions will look like. We'll give you the numbers in the lab. Remember, one student should share screen at a time, but everyone works together on the lab. Timing wise, I think we're going to jump in and see where people are at after about 10, 15 minutes. Ideally, everyone can get to moving the arm to a position using inverse kinematics, and then we can go to the putting things together. Remember, this is the fun, but also the hardest part of the lab. If you haven't finished the programming part, you can decide, TAs help lead the decision, whether you want to finish that part or try to go into the robotics lab and see if you already know enough. All right, questions before I open up breakout rooms again? We also have more TAs now, actually. So it's up to you if you want to stay, but I think one of the rooms you could have one TA per student if you'd like. If that's the case, move to room 1 or 4, and then how about Hillary, bet you can move to that room in case a student wants more personalized attention. Otherwise, I'll just open up the rooms from before. Any last questions? All right, let's do it. Hey everyone, how did the first part of the robotics lab go?
Interesting.
How so?
Um, it's a significant amount of things to think about, even though the information is right there.
Hmm. Yeah,
Um,
it is a lot to put together.
yeah, especially for me because so already doing this with with specific robot brands, everybody has their own proprietary languages. Um, and so it may have different meaning or they may have a different term
Hmm.
versus the Python instruction.
Yeah, the libraries are sometimes different. This one we tried to make as simple as possible, but of course there are going to be differences in libraries, especially ones that are supposed to be more flexible. But thanks for the feedback.
Yep.
Uh,
No, I mean, and what you're doing is very simple, but once you get in a habit, I mean, simple language wise, once you get in a habit, it's like hard to break it, if that makes sense.
yeah, you also don't have access to that much in our little educational language. All right. We're gonna do the wrap up so that way you at least have enough to think about pick and place and finish the lab afterwards if you'd like. So make sure to bookmark the lab or otherwise save it your own copy if you'd like to work on it later. So we've hopefully moved the arm. Now how can we go from moving the arm to actually picking things up? So pick and place is core functionality. You can do a lot with just pick and place. I think I had it on this part. Super useful in manufacturing, and you can do pick and place with a really simple algorithm using tools that you will learn or have already done in this lab. So I'm going to describe the simple algorithm for pick and place on a simple example. So the first is to do a grasp over, is move above the object, open the gripper, move down to the object, and then close the gripper to just a little bit less than the object width. That's picking. So that's how you pick it up. And you already know how to move to above an object or at least move to a 3D location. And then if you can call functions, you can open a gripper and close a gripper. Questions on this grasping sequence? Okay. Then when you're placing the object to put it down, you just do the opposite. So move the object to wherever you want over the table. Lift the object up, move it to above where you want to place it, move down, and then open the gripper. So just reversing, kind of how you probably pick objects, but in a way you can describe to a computer in the same way that you have this very with the instructions we had for making a sandwich. There's plenty of other things that robots do, and a lot of them are just controlling joints, just as we were doing, and picking and placing objects, but in different ways, and with different objects. This is the final activity. Again, in your room, it's up to you whether you want to continue on with the lab or to go to the putting it together part. So option one is robot dance, and there's two versions of robot dance that you can that you can play with without having finished the robotics lab. But the grasping lab will be really hard to do if you haven't finished the going to a position part. So I recommend if you want to go to the putting it together and not finish the beginning parts of the lab, I recommend doing I think the first option for the dance. And then for grasping, do it only if you finish the other parts of the lab. There's also a discussion where, let's say we have a robot and we wanted to pick strawberries. This was a question from TJ. Let's say we have a way of getting the 3D position of a strawberry, write some steps that you can write into code, and then describe the difference between grasping a block and grasping a strawberry. In the breakout rooms, I'm going to set Actually, yeah, first, questions about the breakout room activities, or with the procedures for picking and placing. Okay. I will stop sharing my screen. We actually only have a little bit to work on this before we wrap up and do the like Black and Robotics call to action stuff. So I think I'm going to wrap this up now, and then people can continue working on in the breakout rooms. Desktop one. Okay. So just as a reminder, these were the learning goals, which was changing and writing Python code, commanding the robot to go to joint angles in 3D location, and at least making some progress on some sort of compound robot behavior. Normally we would do this at the end, but since we're pretty short on time, I'm just going to do this before we go back in the breakout rooms for as long as people would like. Going forward, and really now, just click File, Save As in your save a copy and drive to your lab notebook. And there's some other course resources that you can use. You're also welcome to contact any of us over email or social media. And there's, yeah, here are addresses. I think you can also contact us through the Eventbrite link. Then there's some more wait, I think this is actually not up to date, but there's please follow Black and Robotics on Twitter and on Instagram, and you can also join Black and Robotics. You can on the Join Us page in blackandrobotics.org. So I think I'm gonna reopen the breakout rooms. And any questions you can ask your TA, or I'll also be moving around. You can move breakout rooms just as before. I'm gonna try to make, I'll have the original rooms open, but I'll also make room 4 specific to robot dance, I think, if you want to do that. And then the rest will pick out their own.